Who am I? There I am. Okay. Gotta figure out who I am. Okay, cool. Hi everyone. My name is Fraser Kane. I'm the publisher of Universe Today, and I'm here with Dr. Pamela Gay. How's it going, Pamela?
It's going.
You apparently had some kind of holiday over the weekend?
We did here in the United States. We celebrated Thanksgiving, which in no way reflects actually replicating what the original Pilgrims ate or did on their original Thanksgiving feast, because we do things like make pies and, well, as anyone watching Sleepy Hollow knows, they didn't even have sugar back then. So yeah, it was a weekend of far too much eating, and it's now officially time in the United States to start decorating for Christmas. So we put up the tree.
Oh, good, good. Yeah, my daughter is Christmas crazy, so she had us put up the tree as well. And I kept battling her and just battling her. No, there's no stopping it. So I said December 1st. I said, like, December 1st, you can put up the tree. No, no sooner. And yeah, December 1st, it's time to put up the tree. So we put up the
Yep,
tree. Yeah.
it is what it is.
So for people who have no, oh, right, you called Comet Ison.
Yes, I did. I nailed it. It died. Dead comet.
Way to go.
One for Pamela.
Yeah. Oh. Do you feel like you wish things had gone differently?
Well, so I thought about putting together, because I'm an evil person, a betting pool on when it would be pronounced dead and when the images would show destruction, and I'm kind of wishing I'd actually put together that death pool.
You would have sucked money out of me in a heartbeat. Yeah, yeah, I would have totally bet that it was going to survive.
Yeah.
Yeah. Really glad we didn't have a bet.
Well,
Yeah.
it is what it is.
Yeah, totally. Okay. So if people have no idea what we're doing, this is a live episode of Astronomy Cast. We're going to be recording our episode. We'll take about 30 minutes to do it, and then when we're finished, we'll stick around and answer your questions. And we're relying on a new piece of technology, and I know you all love when we implement new technology, which appears to be all the time, because that's how we roll. And so what we're using is there's a tool made by Google Hangouts called the Q&A app, and what it lets you do is it lets you answer questions, or it lets you post questions into sort of a list of questions within the system. Yeah, I see three. There's 3 comments already. So you should now. In the past, this didn't work very well because it only worked in Google Plus. Now it works in Google Plus. It works in YouTube. It works in all of these different locations. So you should, wherever you are, except for mobile, because mobile comes
Mobile.
last. Yeah. So wherever you are, whatever desktop or laptop computer you're using, you should see the little we're answering questions from the audience, and then you can type in your questions in there, and then we will sort of see this nice list, and people can vote for the questions they want answered, and I can sort of put the questions up in live. I'll show you. So Eric Charlin has said, good angle for the webcams, almost if you're talking to face-to-faces in the same place. So I've selected the question and I've put it up somewhere. Somewhere you should see that I am now answering this question. I think at the bottom of YouTube or something. So anyway, and then I can remove it again. So I like this because handling all of the comments has just gotten so complicated. We have to look in YouTube, on Google Plus, in the event page, on Twitter. It's unbelievable. And so now hopefully we have one place that we can answer questions from. So I will try to sort of watch other places as well, but if I don't.
You now know where to go.
Yeah, so yeah, me not looking directly into the camera. See, here's my camera's over here, but I'm
And
actually
mine's over
looking this
here.
way. And yeah, and Pamela's over there. This is a new experiment. We just, like, literally 5 minutes before, we're like, Pamela had set her camera off to the side, and I'm like, that actually looks really good. It looks like we're having a conversation to each other as opposed to staring into the camera. So I think I need to change the camera. I need to have something more interesting than my daughter's
Happy
drawing.
Father's Day.
Yeah, yeah. But if you like the camera placement, let us know. And if you don't, well, we'll keep experimenting. But now you can see my light. All right. So like I said, we'll get rolling on the episode. Today we're going to be talking about Sungrazers, which is really appropriate for poor Ison. And then when we're done, we'll stick around and answer your questions. So how are you in the recording department?
I have to press a button.
Okay.
Tell me
Then
when to press record, and I will consider pressing it.
you'll consider. Okay, I'm ready. Press
Okay.
record.
Okay, I'm pressing record, and the computer is recording.
Nice. In mono.
Yes.
Okay, here we go. Astronomy Cast, episode 324, Sungrazers. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing really well. And thanks to everybody who went onto iTunes last week and put nice reviews for us. Really appreciate it. That's a way that new listeners can find out more information about what we do and get a sense that it's a podcast worth subscribing to and listening to and getting involved in all of the other activities that we're doing. So we really appreciate it. And if you haven't already, go to iTunes, write us a review.
And don't forget, the other way that people find us is through social media. So don't be afraid to share out an episode on Facebook, Twitter, LinkedIn. Heck, you could probably even find a way to Pinterest us with screen capture, although that might be a bit strange. But we're just here trying to get science out to as many people as possible, and we love your help.
Pinterest is actually great because I put all these big astro photos on there. I really like it.
I like it. It's just sharing Astronomy Cast on it because we're an audio show is a bit strange, but go for it. We'd love to see how you do it creatively.
No, totally do it. Share it. Works. Share the video. Works great. So okay, great. So here's let's get rolling then. So comets can spend billions of years out in the Oort cloud, and then a few brief moments of terror orbiting the sun. These are the Sungrazers. Some survive their journey and flare up to become the brightest comets in history. Others won't survive their first and only encounter with the sun. And we are recording this episode the day after, 2 days after, Comet Ison went kablooey. And I guess that's why you picked the topic today.
It's true, and I think it's actually been 4 days, but it was
29th. Yeah, no, you're right. You're
Thursday.
right. Yeah.
And so here we are on Monday, and it was only today that it was finally pronounced dead on perihelion. It took a while to sort out what happened, and what's kind of amazing is how our ability to, follow the progress of these Sungrazers as they orbit has changed over the history of knowing that they're out there. Comet Ison is perhaps now one of the modern era's most famous Sungrazers, but it's certainly not the most famous over history. What's kind of awesome is there's this long history of amazingly bright sungrazer after amazingly bright sungrazer popping up through history, and many of them have been bright enough to see during daylight, where you can actually see essentially a tail emanating away from the sun across the daylight sky.
Yeah, and I think, with Ison, they were really surprised. It was really surprising across the whole process, from when it was discovered to it didn't brighten up, and then it flared up, and then when it finally did make its sort of turn around the sun, it disappeared, but then there was like this puffball when it came out the other side. So it was funny how even NASA were going back and forth, like, it's dead. No, it's alive. No, it's dead. Okay, it's dead. So it was still, you could see there was a lot of things about the behavior of these Sungrazer comets that was quite surprising, even to the people who know all about these things, making the predictions and even what happened afterwards.
And part of this was because the majority of the Sungrazers that we see all belong to one family, the Quartz Sungrazers. And these are all comets that descended from one comet that probably met a very ill fate several orbits ago. So at some point in the past, likely hundreds and hundreds of years ago, there was a great comet that, as it went around the sun, fragmented into many pieces, and periodically those pieces, it was probably two giant pieces originally, those pieces have continued to fragment and have led to the Great Comet of 1843, the Eclipse Comet of 1882, the Great Comet of 1882, and then they started cropping back up in 45 through the mid-60s, and now they're cropping up again just in time for SOHO to start watching them well in the mid-90s forward. So we're used to seeing Sungrazers that all belong to one family of objects. Comet Ison was different. It was originally thought it might have been related to the Great Comet of 1680, but, well, the more we looked at it, the more we realized, no, this is actually a first-timer. This is a raw piece of ice that is on its first journey past the sun, and we're just not used to seeing that, and clearly we were not able to predict how it would behave.
Right. So I think that's sort of part of the surprise here, is that so many of these Sungrazers source back to one object.
Right.
That can you just imagine what that must have looked like after it went past the sun?
Well, it's hard to imagine, specifically when we start looking at what its fragments were able to do. The Great Comet of 1843, its tail was 2 degrees wide. Its length was 45 degrees across the sky. So when you looked at it, so the moon's half a degree. So its tail was 4 moons wide on the sky.
And it was like halfway from the horizon up to the very top of the sky.
Right. And it was visible during the day, which meant that you could actually see it for a while as this tail growing away from the sun. So that's really kind of an amazing thing to think about. And this was one of the fragments of the original comet. So yeah, whatever it was initially must have been something absolutely amazing. It's thought that maybe it was the Great Comet of 1106, but it's just not quite clear. But the fact that the Great Comet of 1106 occurred in 1106, and there's records of it, because there's not a lot of astronomical records from that era. But on February 2nd, all across the world, people began to notice that particular comet. And, well, hopefully we're starting to understand how that one fragmented, the orbits decayed, the fragments spread out, leading to more and more of these Sungrazers that we're now seeing today.
So then, like, what do scientists define as a Sungrazer?
It's simply a comet that gets well within the Mercury sun distance, and often it gets closer to the sun than, well, the moon is to the Earth. And this isn't to the center of the sun, that would be inside the sun, but the distance between the surface of the sun and the surface of the comet is often less than the Earth-Moon distance.
Right, and that's like 350,000 kilometers, and the sun is like, what, 1.4 million kilometers across, so it's close.
Yes.
And so you can so what happens to these poor comets? What are the forces, the stresses? What's going on to them?
Well, so it's experiencing 3 different factors. On one hand, you do have the tidal forces. This is the difference in the gravitational pull on the near side and the far side of the comet that is working to pull it apart, just shred it. These comets are held together with both gravitational force and chemical properties. And so the tidal forces are working to overcome both of those forces. The tidal forces don't have very long, because these comets are often traveling as fast as 500 kilometers per second. But that can be a long enough time to break a comet up that way. The other thing that it's dealing with is the sheer heat. The radiation of the sun is transferring energy, which is raising the temperature at the surface of the comet. And Well, comets are made primarily of frozen stuff, frozen oxygen, frozen water, frozen carbon dioxide, frozen nitrogen, um, all these different frozen things, ammonia, that's where the nitrogen's hiding. All these different frozen things, when they get heated up, they make the transition from solid to gas. And so this is where you can see jets sticking out the sides of comets as they fly. Those jets are actually where the icy particles are sublimating away, and any dust that was trapped in the ice is then acting to reflect the sunlight back at the observer. And then the third thing these things are dealing with is they're getting beat with the solar wind. So there's actually this constant flux of particles coming off of the sun, and that's also beating, although that's by far probably the least effect that they're dealing with. All of those things are also beating on the surface of the comet. So this causes the volatiles to react. It causes organics to form on the surface, usually at greater distances. And depending on the structure of the comet, if it's a lumpy comet that's only kind of held together with gravity and actually basically a rubble pile, just the jets from the volatiles sublimating can blow the thing apart. If it's a more solid, I don't know, iceberg-like comet, it may have a better chance of surviving, of glazing over with organics and protecting itself a little bit better. But it's certainly a harsh ride, no matter how the comet's formed.
Yeah, I mean, when we think about comets versus asteroids, right? We think of asteroids as balls of metal or balls of rock. They would handle that kind of a pass, depending on if they might get torn apart depending on their piles of rubble or whatever, but they might just almost reform again. They'll go around they'll come back together. But in this case, you've got, as you said, you've got this terrible tidal forces tearing apart, and then this enormous stream of material that's trying to radiate it away, and so they can't pull themselves back together. They can't handle it.
And you have the gas expanding. It's imagine the comet's filled with a bunch of exploding balloons, and that's pretty much what's happening.
Again, just imagine what it would be like to be standing on the surface of a comet and seeing this stuff happening, all of these vents opening up and streams coming out and things bubbling and boiling away.
And
amazing.
This is actually something that you can simulate, and if you go over to CosmoQuest, we actually have the recipe. The stuff that comets are made of are all things that we can find here on Earth, and in fact, most of us can find most of the ingredients just by going down to the local grocery store. If your grocery store happens to have dry ice, or most towns have an ice store that has dry ice. And you can mix together corn syrup, ammonia, water, dry ice, and pack it together, add in some dirt from the yard, and set it in front of a light and a fan, and watch what happens, and essentially watch the evolution of a comet sitting on your desktop.
Yeah, Nicole, our good friend Nicole Gallucci, did this experiment, made a comet during our Ison special, and it was great. It just worked out perfectly. She, brought all these ingredients together and packed up the big snowball. I wouldn't want to get hit by it, but yeah, it's really cool. So if you can dig that up, look at our Ison special that we did a couple of weeks back.
The links are on cosmoquest.org/blog. Just check out our blog and find all the stuff that we've been doing, so that, well, you can recreate your destroyed comet.
Now, one of the things that I think people are quite surprised at is that the SOHO mission is actually the most prolific comet discoverer out there, and it's finding comets moments before they're destroyed.
Right.
It's hilarious.
So the problem that we normally deal with is the sun's kind of a bright thing, and these comets are often tiny, meters to dozens of meters across in some cases. And as they get close to the sun, they grow a tail, they become highly reflective, and that tail is spread out over a great deal of space, and that's why we're able to see them. But all of this is happening within a few degrees of the sun on the sky, and we're not going to see them with our eye. And one of the crazy things is there's actually one of the 1882 comets was only discovered because it was seen during a solar eclipse in Egypt. Well, we don't have to wait for solar eclipses to see the region around the sun when we use SOHO. It has a coronagraph. And that plate that's blocking the sun's light allows us to see fainter objects that are down near its surface. And so we're able to catch all of these icy fragments as they make their suicide journey around the sun. So for the first time, we really are able to catch fragment after fragment of these Crute sungrazers and other sungrazers that come from the outer parts of the solar system.
So if a thing just crashes into the sun, is that a sungrazer?
Yes.
Right.
It's one that kind of failed to graze, but yes, it's a sungrazer.
Yeah, it grazes, yeah. So how many of these sungrazers are there? I mean, how many has SOHO found?
Well, since it launched in 1995, it's found over 2,400. So there's a lot. And they aren't all part of the Crute's sungrazer family, but many of them are. So again, that starts to give you an idea of how a comet fragments. And these things can start as several kilometer across cores. Ison was estimated to be, by some estimates, 2 kilometers across. And so you start with something that's several kilometers across and just progressively break it up over time until you have chunks that are meters across. And the forces that fragment the comet also cause slight differences in the velocity of each of the fragments, which causes them over time to spread out in their orbits. And that's why we see them year after year. And what's kind of neat to think is it's estimated that we're due for a bigger chunk. And so maybe we're due for another great comet that will be visible during daylight.
We're totally due. We're absolutely due.
You were so certain it was going to be.
I was so certain. I was so ready to enjoy this comet, even though I would have to get up in the morning, early in the morning, and go watch it. I was ready. Because, I mean, Hyakutake and Hale-Bopp were so great.
Well, they had the advantage. They were older. This means that they had organics built up on their surfaces, which kind of forms a sludgy crust. A lot of these Crute's comets, they're also older fragments. And when you have an older fragment that's pretty solid, it's survived several times, it's had time for more of its volatiles on its surface to go away, it builds up that crust, well, that's just a little bit more stable. Now, what's interesting, though, is Hale-Bopp may become the next Crute's. It may someday, there's a 15% probability that over the eons, orbital perturbations are going to cause it to, well, get closer and closer to the sun at perihelion. It'll probably fragment. It's actually thought that maybe it's already a fragment of a past great comet. So we could end up with a whole new family of sungrazers someday in the future.
So where do these objects come from in the first place? I mean, we talked about the Kurtz comets that are like some object that they're just, you know, it's the fragmented particles of some comet, and they're just going around and around the sun. Where did that object originally come from?
Well, comets in general come either from the Oort cloud, which is a not yet really detected sphere of icy bodies far out in the outer edges of our solar system, or they come from the Kuiper belt, which starts out around the orbit of Neptune and extends out to, we're not quite sure, but somewhere in the 80 AU range. Comets in general, due to orbital perturbations, have a strong probability of becoming sungrazers. It's unclear exactly how many are likely to become sungrazers, but any individual comet has a tens of % chance of, over time, should it not die on its early orbits, becoming a sungrazer. And comets can die in many different ways. They can dive into Jupiter. They can dive into Saturn. We've seen them diving into Jupiter in the past. Comet Shoemaker-Levy 9 did that in, I believe, 94.
Yeah. 97? Anyway, yeah.
No, 94.
Yeah.
But should they survive other encounters in the solar system, over time, their perihelion distance, their closest approach to the sun, is going to get moved closer and closer in on the solar system, or closer and closer in on the sun. And eventually they graze the sun and eventually they die.
Right, right. And so you get this situation where originally it's perfectly fine, some perturbation hits it, it ends up on one of these orbits, crosses the sun, and either like Ison, just that's that. It
Right.
was a nice ride and then it's dead, or it survives and then can break apart and come back around multiple times. But eventually, once it starts that sun grazing process, it's a goner, right?
Yeah, it's thought that maybe all of the comets that come within 2 AU of the sun, so come within twice the Earth distance, have a 15% or greater chance of becoming sun grazers. Uh, so it just depends on what's the fate. And, well, we need to see more of these to really understand what's going on, and we need more data. It's always a matter of more data. So hopefully we'll get more chances like Comet Ison um, to watch fresh bodies come in and die brutal deaths.
Now, we had a great sort of view this time with Ison because there's a bunch of spacecraft out. There's not just SOHO. There's SDO. There's Hinode. So all of these have different sort of fields of view on the sun, and it was great to watch the comet come into one field of view and then into the next one. So do you
And,
think our detections are going to go up, or?
well, so the way we were able to observe it was actually pretty interesting because we had, as it went in from one angle, we followed it with SOHO. As it wrapped around the back, we were able to see it with Stereo, which is currently aligned such that it can look behind the sun for us. SDO wasn't actually able to see it as it got too close to the sun. But this fleet of sun watching satellites, each of them have slightly different jobs, each of them have slightly different sets of detectors, and once we find a comet, each of them can play a different role. The reality is SOHO's field of view with its coronagraphs, its L2 and L3 systems, those are perfectly set up for finding comets. They offer a nice wide field of view, and it's that larger field of view with that blocked out sun that really makes them perfect for finding sun grazers. Many of the other instruments, well, you see the entire disk of the sun, and, well, if you have your detector adjusted to not die a nasty death from sunlight, it's not going to be able to see the fainter objects.
Yeah. And so if you're just a regular person and you want to participate in this, you can go to SOHO's website, live website, and find these comments, right?
Right. So all of the data from SOHO is live pretty much in real time. Data comes down, they process it, it goes on the web. It's an automated process, and you can download the images. And there are individuals who've found tens to over 100 of these different objects. And they do it by looking at image after image after image, sometimes in automated ways using software like MaximDL or APES or whatever it is that's out there they want to download to process images, and they look for things that are moving in a set way, and they can calculate orbits and submit what they discover to the Minor Planet Center out in Boston.
And what does the Minor Planet Center do?
Well, they log, is this new? They log, is this accurate? And if you have enough measurements on your orbital elements, it ends up named after you. That's the way comets work.
Right. That's the great part. And so there aren't many objects. You can't name a star after yourself, and you can't name a planet after yourself or a galaxy, but you and if you want to name an asteroid, it's a bit of a fight. But if you want to name a comet,
you just have to discover it, which
you just have to discover it, yeah.
Isn't always easy, but you're out there competing against all the other amateurs doing it, and there's a chance you'll be the winner who gets the comet on its way to death. So you get to name something in the process of dying after yourself.
That's why there's been multiple Comet Lovejoys, because
Yes.
Terry Lovejoy in Australia is a machine at finding comets, and he just keeps getting them named after himself.
Yep. And that's why you have the entire nomenclature, which is C for comet / name of the human and then the year. And then there's also usually a type. So you'll have, for instance, C / 2011 W3 Lovejoy. W3 tells what type of comet is, and then Lovejoy says who it was that found it.
And so now, as we stand right now, we've lost Dyson, but there's actually 4 other comets that are visible in the morning sky with binoculars. So we did a roundup of it in our most recent weekly space hangout. But so there's still comets. You just need binoculars to see them, and there are more being discovered all the time.
And you know, if you don't keep looking up, eventually the universe is going to throw something at us to get our attention. So keep looking up, discover everything there is to discover, and a great pair of binoculars is all you need, along with an internet connection to keep track of things, so that you can go out and find all of these faint fuzzies in the night sky for yourself.
Very cool. Well, I'm disappointed, but I still am holding out hope that in the next couple of years we will have a great comet, something with one of those big, long tails that you can see without binoculars, just the unaided eye. I can't wait.
We need another Hyakutake.
Totally need, or a Hale-Bopp. Yeah, those two. That's the class. That's what I'm waiting for. The universe owes me a comet. So.
The universe owes you nothing. It's just trying to kill you.
Right, of course, with comets. Well, thank you very much, Pamela.
My pleasure. And now we save.
Save. Got to save.
And we'll answer your questions as soon as we have our files closed and saved.
And lots of good questions. This is great. I think this Q&A app is going to work like a charm. And I know a lot of people are having some problems with it, so we need to figure that out. All right. Saving. Then I will upload.
And I'm just updating all the pages.
Whoa, now I'm the one with a hard drive that's almost full.
Oh no.
Yeah, I better clear that up. The problem is these like Dropboxes and things like that, they replicate on your hard drive, and so.
Oh, you can custom what is.
No, I know. Yeah, no, I know. It's just don't notice, and then boom, hard drive's filled. Boring. Best show ever. Sorry, I'm having trouble managing these episodes. Here we go. And done. Safe, but for how long? Okay, cool. So let's see some questions here. So I will select the question here. This is awesome. Okay, so Graham Sticking says, is it possible for amateurs to get access to the raw images from SOHO to look for these Sungrazers, and if so, how? Now, you said that they download the images, they process them, they put them up on the internet. Is there a rawer version of that?
I actually don't know. A lot of these missions, they create so much data, and you don't really want the raw images. You want the ones that have all of the flaws in the detector cleared up. You want to see what they look like when they're fully processed, because there's a lot of flaws in these detectors. You want the flat fielding and everything else. So I'm not sure if you can, through any normal means, get a hold of the non-processed images. If you can, it's probably available through the Planetary Data System, which is one of NASA's repositories of all things spacecraft. So look for the Planetary Data System and see what you can download.
To try and get a jump on everybody else to find your comments. So Sylvan Westby says, if SOHO finds hundreds of comets per year in that small of a volume around the sun, the inner solar system must be a shooting gallery of unpredictable comets. Why do we even bother searching for well-behaving asteroids? We are doomed. Well, we know we're doomed. The universe is trying to kill us. This is just another way the universe is trying to kill us.
Well, and the good thing is most of these objects are on a high enough inclination that they're going above the plane of our orbit, dive bombing around the sun, and then going below the plane of our orbit. So that most of the Sungrazers that we're looking at all belong to this one family of objects that is mostly staying out of our way. Mostly.
Eric Charland says, "What binoculars do you recommend for those comets still around?"
I like 10 by 70s, either something by Nikon or by Orion or Canon. I personally, I think I own both a pair of Nikon and a pair of Canon.
Yeah, beyond, I mean, the 10. So the 10 is the magnification. The 70 is
Light
the
gathering.
light gathering, the size of the lenses. Uh, 25 by 100s get really heavy, and you need a tripod. So, as you said, 10 by 70 is sort of a nice handheld. Even that gets a little exhausting. The 70s are pretty big. So, um,
If you're
I.
lying on the ground with your elbows braced,
Mhm.
they aren't that bad. Um, and they're kind of at the price point where it's not evil, and you can forgive yourself for spending the money.
Yeah, I mean, I would start with like a 1050. In many cases, you've got like a 1050 kicking around, and they're
Yeah.
not expensive to get. And if you dig it, then go up to a 1070. The other thing is, if you want to get really serious, we played around with some image stabilizing binoculars when we were on the cruise to the end of the world last year, and they take with a smaller focal length, you get a better image. I mean, we were playing with some. They were what, 10 by 35s or 10 by 50s, but they're image stabilized, or 15. Anyway,
Yeah.
unbelievable. Just the how well the image stabilizing system works, because you look up and everything's jiggling around. You press a button and everything just
Clicks.
gets perfectly still, and it's just gorgeous.
And the one thing you want to be careful of is there's binoculars that are sold for things like ball games and operas and outdoor concerts, and they don't have any anti-reflective coating. And this means that some of the light that's hitting them is just going to get reflected off of the surface of the lenses. Now, there's always going to be a certain percentage of the light that gets reflected instead of getting transmitted through the lenses. But if you have one that when you look at it, it has more of a purple overcoat, that probably has anti-reflective films on the surface. And those films will help a larger percentage of the light get transmitted all the way through to your eye, allowing you to see fainter objects.
Yeah. Okay, so Alta Productions 878 says, "How long did Ison's journey to the sun take?"
All the way in, it took hundreds of years.
I mean, from like longer? I mean, I mean, it could have been like the Oort cloud is 10,000 AU. I mean, it's far, right? Depending on where it came from.
Yeah, and unfortunately, because this sucker has a hyperbolic orbit, we can't calculate where it started, which is really annoying. So all we can do is offer guesses, and our guesses could be amazingly wrong.
Yeah, so the Oort cloud goes out to tens of thousands of astronomical units, from thousands to tens of thousands, and it is, I mean, who knows where it came from?
And we're only estimating that it came from the Oort cloud based on, well, what it appeared to be made of and what its orbit was. But we don't know for certain.
Let's see. Guido Bieber asks, "Do we know exactly how a comet gets catapulted out of the Oort cloud, or is it still a mystery?" And then he gives us some technical information. So did we answer that one? Perturbations. They bump into each other.
Well, it's not just perturbations between one another. That's the bulk effect, but we also suspect that periodically they get perturbed by passing stars and the effects of things external to our system perturbing orbits. So the three-body problem, you get three things tumbling close together, one gets ejected. That probably accounts for the majority of what's going on, things slamming into each other, fragments getting sent our way, more rare. And while more rare, you can still get large numbers of things perturbed if we pass too close to another star.
Walter Obz says, "What's the mass of the Oort cloud relative to the planets? How much of that stuff is out that far?"
Google. I don't know.
Yeah, I don't know either.
It's a very small percentage. The bulk of the solar system's mass is tied up in the sun, then Jupiter and Saturn, everything else is just fragments.
Yeah, it's like 99% of the whole solar system is the sun.
Yeah.
Okay, here we go. So somebody asked, P.W. Pollard asked, what are the names of the four remaining comets? So we've got Comet C 2013 V3 Nevsky. We've got Ison, which is now gone. What are the others? There's a Lovejoy. Linear. Okay, so we got X1 Linear. We've got 2P Enki and R1 Lovejoy. So those are the four comets. Linear, Enki, Lovejoy, and Nietsky.
And
Nevsky.
Enki's another person who finds them regularly, and Linear is a survey that finds them regularly. So you can see how things just constantly build up with similar names because there's not a lot of people searching.
Paul Gracie asks, so is Ison now part of the sun? Is part of Ison now part of the sun?
Probably some of it fell back into the sun, but the bulk of it, from looking at the images, got poofed, and then solar radiation pressure would have just driven the gas out. The cloud of dust that we see right now, that's the organics that were tied up in the comet. When all of the volatiles sublimated, went poof. That dust got scattered, and when the dust was initially close together, it reflected brightly. As it spread out, it's continuing to reflect, but that area of light is getting spread out over a larger and larger volume. So its surface brightness is the fancy word we use, is going down.
But I imagine it like you go to NASA and you get into one of their wind tunnels, and then you bring one of those nice homemade comets and you just sort of throw it up in the air, and they're just going to get blown apart, and the pieces are going to get thrown that way. I mean, to try and fall down into the sun when it's dealing with all of this outbound solar radiation and solar wind and such, it's pretty tough to fall down into the sun, right?
But gravity does suck.
Gravity sure does, yeah. Okay, so Thomas Tranaker suggests Swarovski. How do you say that? Swarovski binoculars, 8x42 if you can afford them.
Oh, I don't know those.
Yeah. So there you go. There you
Okay.
go. There's a recommendation from Thomas, and Thomas knows his stuff. So, boy, all kinds of things. Here we go. So Lance INTJ says, do you have any recommendations for a solar filter?
Yeah, the Bada filters are really nice. Just plain Jane film filters that cut down the white light until you can see the surface of the sun. And then the Coronado H alpha telescopes are amazing if you want to see all the details of the corona of the sun.
Yeah, so when you see those really wonderful pictures of the sun where you can see like the granules on the surface and you can see the prominences poking up and stuff, that's all using these H alpha filters. So they
Not
do
cheap.
come cheap. No, they're hundreds to thousands of dollars if you get really high quality ones. So
But the Bada filters, you can get them for binoculars, you can get them for telescopes, you can make them yourself by just buying a bunch of the film. It's perfectly reasonable.
yeah, and then you're looking at the sun. You're seeing sunspots. Good times. Okay, so ATPL 2074 asks, does the Oort cloud really exist? What is the evidence? How long before Voyager reaches it?
So we have every reason to believe it exists. We do see icy chunks on a random basis that have orbits that seem to imply that it exists. Sedna is the first object that we found that has an orbit that seems like it could be an Oort cloud object. The problem is that we're looking for things so far away and so small that we don't actually have the means to just outright stare at them directly when they're out in the Oort cloud itself.
Yeah, so I mean, it's like the evidence for the Oort cloud is comets. So, is there a place where comets come from? Well, there appear to be comets coming from a place. So that's all we got, right?
Yes. And what's interesting is people do all sorts of things trying to find it, looking at polarization in the cosmic microwave background, looking at dimming, and because the sucker's a sphere, that just makes everything more difficult.
Yeah, now there have been some interesting missions proposed, and I'm trying to think, we did a story on it a couple of years ago that someone had proposed a mission, an Oort cloud class mission, as almost like a precursor to an interstellar mission, that you would create a probe that would go super fast and get really far out and but it also had a pretty good telescope on it, and it would try to find some inner portions of the Oort cloud and then try to steer itself toward those and try and make a close-ish pass of an object. But it would be at a scale 10 times our current, most interesting, most expensive, capable missions. I mean, the
You'd
scale.
essentially have to launch James Webb on the trajectory of New Horizons. And when you think about the fact that New Horizons was not cheap and is essentially an off-the-shelf Celestron or Meade or whatever size telescope, yeah.
Yeah, so it is an order of magnitude more complicated to try and actually find the Oort cloud. And so the best thing that we can have is when the Oort cloud comes to us, which are these comets.
And I'm not even sure it's only one order of magnitude.
Yeah, no, at least it is the
Yeah.
precursor of an interstellar mission. So that part's kind of interesting, which is that if you can pull off portions of this, you're moving towards being able to actually, to send a probe out into the inner regions of the Oort
Right.
cloud within a reasonable amount of time. You're starting to master some of the technologies that you would need to send up robotic spacecraft to the nearest star. It's
Right.
because that's another order of magnitude above that. But it's like that's the very challenging. But there's so many things that I would way prefer personally that we see, like great big interferometers,
Terrestrial
space-based
planet finder.
terrestrial planet finders, for example. Yeah, that's what I would love to see in the near term. But it's great. But it's funny that people say this. I mean, like, what is the evidence for the Oort cloud? The comets. That's it. That's all we got.
It's raining comets.
It's raining comets, so the comets are coming from somewhere. That's all. Yeah. Jamie McIlvaney asks, is there a great scientific merit in the breakup of ISIN, or is it now a lost opportunity?
Nothing's a lost opportunity if you gather all the data you can. We're still figuring out what we figured out by observing this. We saw a fresh new comet enter the solar system, potentially fragment a couple weeks ago, as we saw changes in its tails, get close to the sun, go poof in an unexpected way. There's so much data, it's going to take months to possibly a year or more to get it all together and start figuring out what all we learned. Destroying something is just as interesting as watching it not get destroyed, and if you have the right data, which I'm hoping we have, when something gets broken apart, you get to learn more about what it's made of, what its composition is. And that starts to tell us the building blocks of our own solar system, and that's pretty cool.
Yeah, I mean, it was such a great observed mission. So I mean, there was multiple times that Hubble was directed at it to view
Right.
it, and then it was seen by SOHO, and then it was seen by Stereo, and then and now we see the results of what's
Right.
happening as it leaves, and it's going to continue to be observed. And so the next time a comet's going to make this kind of a trajectory, they'll be able to take the data they discovered this time around and try to better understand it. But also, in this case, the sun took one of these comets, which is this collection of material with lots of secrets inside, and went, boom. Take a look what's inside if you want.
Right.
Like, feel free to examine every part of this comet. Here it is, all of it. And I think that's going to be great. I mean, I'm sure a lot of scientists are way happier that it got shredded.
And I've seen indications that Hubble may be looking at that blob of dust once it gets far enough away from the sun. You can't point Hubble too close to the sun because it would just be all kinds of bad for the system. But hopefully, once that cloud of expanding dust gets far enough away from the sun, it will still be reflecting enough light that we can get better indications from Hubble exactly what that cloud of dust is made of.
Is Enki going to be a stargazer? Asks Green Moldy Cows. I don't know. I don't think so.
I love that username.
I know, it's pretty funny. I don't know. You can see the orbits of all things. The Solar System Dynamics JPL Small Body Database Browser is the tool you want to use. You can find any object, put it into that, and you'll see the orbit of it. So, and it lets you sort of run it back and forth through time and see its interactions. So, yeah, do
And
go
you
to the.
can rotate it.
Yeah, you mentioned it was the Minor Planet Center. So if you go there, you can get access to pretty much every object that we know about and examine their orbits to your heart's content. And I don't know if it's going to be a Sungrazer. I don't think so. We would have heard that. Andrew Planet asks, could we use a comet like a rocket, landing a spacecraft on it to take it to the outer solar system? Well, you have to get your spacecraft moving 50,000 kilometers per hour to catch up with the comet, right? To land on it.
Well, it depends on the comet, where it is, the differential velocities and all that, but the real problem is the surfaces of these suckers are not the healthiest places to try and land. You're talking about a volatile surface that has gas geysers erupting haphazardly. Some of these things are basically powder puffs. When Deep Impact impacted the comet that it hit a few years ago, it didn't even leave a well-defined crater because the surface just was powder. So trying to land on one, not safe for anything involved.
There's going to be an interaction with Rosetta in the next.
Yes.
I'm trying to think when that's going to be. 18? 21? Anyway, we're within a decade of when Rosetta is going to be reaching its target, and it's going to be smashing into it. I think, is it going to try and land on it? It's got a little probe.
I don't know if it's trying to land or if it's impacting.
Yeah, it's got Hidalgo. It's got a little mission on it. It's got a lander, I think. Let me just see what the objective is. And they're going to try and.
They wake it up in 100 days.
Yeah, okay, so it's going to reach the comet by mid-2014. I'm trying to think of what else is going to happen. It's going to follow the comet. Yeah, it's going to land on the comet in November 2014. Wow, that's really soon. I've been reporting on it for so long. I didn't realize that I remember when we first heard about the mission, I was like, oh, that's so long from now.
Yeah, it launched in 2004, so this is an 11-year mission.
Yeah. Okay, so it's going to try and land on the comet in November 2014. So a year from now, it's going to land on a comet. So that's going to be awesome.
And what I love is, so the lander gets delivered November 2014, and the mission ends December 2015, with a perihelion passage August of 2015. So expect lots of answers to how violent the surface of a comet is coming in the future.
Right. The lander is named Philae, and it's got 2 harpoons that it's going to shoot into the comet. And then it's comet Churyumov-Gerasimenko, and it's going to fire these harpoons in to hold on while it lands on the surface to try because as we mentioned, You've got all these blasts of pockets of gas that are coming off of it. So wow, that's going to be a crazy mission. Oh, I can't wait. God, 2014, we're so close. I'm getting so excited about New Horizons, but that's in 2015. This is it. This is my new thing to get excited about. I'm stoked. Let's make it happen. Cool. Okay, well, we're run up with our hour, so I think we're going to have to wrap things up. So thanks to everyone. By all means, give us some feedback in other places about how you like using the Q&A app. We got tons of questions. It was nice and organized. I was able to display them on the screen. I was really happy with that. I know people on mobile devices are bashing their phones right now because they weren't able to see it, but please let me know what you folks thought of that. Yeah. So what's happening this week, Pamela?
We are going to have the weekly Space Hangout on Wednesday. I think we may have a Dawn Mission Hangout this week. And, well, as we head into the Christmas time, expect some holiday surprises to celebrate Newton's birthday if that's your thing. Newton Miss Christmas. And there's going to be some neat audio coming out.
Merry Newton Miss. I like that. Because his birthday was on Christmas, right?
Yeah.
Yeah. So you've got Learning Space Wednesday, Space Hangout on Friday, Virtual Star Party on Sunday.
Yeah.
Rinse, repeat. And then you need to pick a topic for next week for Astronomy
I do.
Cast. Awesome. Cool. Okay, well, thanks everyone for watching. Pamela, thanks as always for lending us your brain. We really appreciate it. And I cede to you that Ison was destroyed. I'm really glad we didn't make a bet.
The universe owes you nothing.
All right, we'll see you later.
Okay. Bye-bye.
Some survive their journey and flare up to become the brightest comets in history. Others won't survive their first and only encounter with the sun. And we are recording this episode the day after, 2 days after, Comet Ison went kablooey. And I guess that's why you picked the topic today.
It's true, and I think it's actually been 4 days, but it was
29th. Yeah, no, you're right. You're right. Yeah. Yeah.
And so here we are on Monday, and it was only today that it was finally pronounced dead on perihelion. It took a while to sort out what happened, and what's kind of amazing is how our ability to, well, follow the progress of these Sungrazers as they orbit has changed over the history of knowing that they're out there. Comet Ison is perhaps now one of the modern era's most famous Sungrazers, but it's certainly not the most famous over history. What's kind of awesome is there's this long history of amazingly bright sungrazer after amazingly bright sungrazer popping up through history, and many of them have been bright enough to see during daylight, where you can actually see essentially a tail emanating away from the sun across the daylight sky.
Yeah, and I think, I mean, with Ison, they were really surprised. It was really surprising across the whole process, from when it was discovered to it didn't brighten up, and then it flared up, and then when it finally did make its sort of
it's dead, and when the images would show destruction, and I'm kind of wishing I'd actually put together that death pool.
You would have sucked money out of me in a heartbeat. Yeah, I would have totally bet that it was going to survive.
Yeah.
Really glad we didn't have a bet.
Well,
yeah,
it is what it is.
Yeah, totally. Okay. So if people have no idea what we're doing, this is a live episode of Astronomy Cast. We're going to be recording our episode. We'll take about 30 minutes to do it, and then when we're finished, we'll stick around and answer your questions. And we're relying on a new piece of technology, and I know you all love when we implement new technology, which appears to be all the time, because that's how we roll. And so what we're using is there's a tool made by Google Hangouts called the Q&A app, and what it lets you do is it lets you answer questions, or it lets you post questions into sort of a list of questions within the system. I see three. There's 3 comments already. So you should now. In the past, this didn't work very well because it only worked in Google+. Now it works in Google+. It works in YouTube. It works in all of these different locations. So you should, wherever you are, except for mobile, because mobile comes last. Yeah. So wherever you are, whatever desktop or laptop computer you're using, you should see the little we're answering questions from the audience, and then you can type in your questions in there, and then we will sort of see this nice list, and people can vote for the questions they want answered, and I can sort of put the questions up in live. I'll show you. So Eric Charlin has said, good angle for the webcams, almost if you're talking to face is in the same place. So I've selected the question and I've put it up somewhere you should see that I am now answering this question. I think at the bottom of YouTube or something. So anyway, and then I can remove it again. So I like this because handling all of the comments has just gotten so complicated. We have to look in YouTube, on Google+, in the event page, on Twitter. it's unbelievable. And so now hopefully we have one place that we can answer questions from. So I will try to sort of watch other places as well, but if I don't,
you now know where to go.
yeah. So yeah, me not looking directly into the camera. See, here's my camera's over here, but I'm
And
actually
mine's
looking
over
this
here.
way. And yeah, and Pamela's over there. This is a new experiment. We just like literally 5 minutes before, we're like, Pamela had set her camera off to the side. And I'm like, that actually looks really good. It looks like we're having a conversation to each other as opposed to staring into the camera. So I think I need to change the camera. I need to have something more interesting than my daughter's.
Happy Father's Day.
Yeah, yeah. But if you like the camera placement, let us know. And if you don't, well, we'll keep experimenting. But now you can see my light. All right. So like I said, we'll get rolling on the episode. Today we're going to be talking about Sungrazers, which is really appropriate for poor Ison. And then when we're done, we will we'll stick around and answer your questions. So how are you in the recording department?
I have to press a button.
Okay.
Tell me when to press record, and I will consider pressing it.
You'll consider. Okay, I'm ready. Press record.
Okay, I'm pressing record, and the computer is recording.
Nice. In mono.
Yes.
Who am I? There I am. Okay. Gotta figure out who I am. Okay, cool. So, hi everyone. My name is Fraser Kane. I'm the publisher of Universe Today, and I'm here with Dr. Pamela Gay. How's it going, Pamela?
It's going.
You apparently had some kind of holiday over the weekend?
We did here in the United States. We celebrated Thanksgiving, which in no way reflects actually replicating what the original Pilgrims ate or did on their original Thanksgiving feast, because we do things like make pies and, well, as anyone watching Sleepy Hollow knows, they didn't even have sugar back then. So, yeah, it was a weekend of far too much eating, and it's now officially time in the United States to start decorating for Christmas. So we put up the tree.
Oh, good. Good. Yeah, my daughter is Christmas crazy, so she had us put up the tree as well. And I kept battling her and just battling her. No, there's no stopping it. So I said December 1st. I said, like, December 1st, you can put up the tree. No sooner. And yeah, December 1st, it's time to put up the tree. So we put up the tree. Yeah.
It is what it is.
So for people who have oh, right, you called Comet Ison.
Yes, I did. I nailed it. It died. Dead comet.
Way to go.
One for Pamela.
Yeah. Oh. Do you feel like you wish things had gone differently?
Well, so I thought about putting together, because I'm an evil person, a betting pool on when it would be pronounced.
Okay, here we go. Astronomy Cast, episode 324, Sungrazers. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing really well. And thanks to everybody who went onto iTunes last week and put nice reviews for us. Really appreciate it. That's a way that new listeners can find out more information about what we do and get a sense that it's a podcast worth subscribing to and listening to and getting involved in all of the other activities that we're doing. So we really appreciate it. And if you haven't already, go to iTunes, write us a review.
And don't forget, the other way that people find us is through social media, so don't be afraid to share out an episode on Facebook, Twitter, LinkedIn. Heck, you could probably even find a way to Pinterest us with screen capture, although that might be a bit strange. But we're just here trying to get science out to as many people as possible, and we love your help.
Pinterest is actually great because I put all these big astro photos on there. I really like it.
I like it. It's just sharing Astronomy Cast on it because we're an audio show is a bit strange, but go for it. We'd love to see how you do it creatively.
No, totally do it. Share it. Works. Share the video. Works great. So, okay, great. So here's, let's get rolling then. So comets can spend billions of years out in the Oort cloud, and then a few brief moments of terror orbiting the sun. These are the Sungrazers.